Hello everyone and welcome back. In this lesson we are going to be looking at the relationships between the roots of a quadratic equation. Let us start this discussion by looking at the general equation ax squared plus bx plus c equals 0 with roots x equal alpha and x equal beta. Now, if x equal alpha is a root, then we understand that x minus alpha is a factor. Likewise, the same thing, if x equal beta is a root, then x minus beta is a factor. And we can expand this to get a look at what the quadratic equation should look like. So here we go, x times x gives us a x squared. X times a beta gives us a minus beta there, gives us a minus beta x. Alpha times x here will give us a minus alpha x. And minus alpha times minus beta gives us plus alpha beta equals 0. We can tidy that up a little bit by writing it as x squared, factoring out our minus here, minus alpha plus beta x, and plus alpha beta equals 0. So given that this equation had these as its roots, then this equation is somewhat similar to this one, except for the point that this equation has a coefficient here, x squared of 1, and this has a coefficient of a. So let's just go ahead and do something about that. So here we have ax squared plus bx plus c equals 0. And what we want to do is to get a coefficient of 1 here so that it will match this one directly. And so we'll go through and divide the equation by a. And if we divide that equation by a, then what we get here is x squared plus bx over a, or b over a times x, plus c over a, and that will be equal to 0. Now these two equations are directly comparable. So we have an x squared here, we have an x squared there, and then we have minus alpha plus beta here, x, and b over ax. And what that is telling us is that minus alpha plus beta is equal to this here, which is b over a. And we can write this a little differently by multiplying both sides by -1, and what we end up with is alpha plus beta is equal to b over a with a minus here. So alpha plus beta would be equal to the minus b over a. And what that is telling us is that the roots, which are alpha and beta, that is, if we add them, a plus b, we get minus b over a. So the sum of the roots of the quadratic equation with roots x equal alpha and x equal beta, the sum of its roots is given as minus b over a. Now the product of the roots, so notice that here, when the two roots are multiplied, alpha and beta, when they are multiplied, it gives alpha beta here. And so here, alpha beta would be directly comparable to c over a. So alpha times beta would be equal to c over a, and that is what we have as the product of the roots. And what we're saying is that in any quadratic equation, once it has real roots, when we talk about them, then the sum of the roots is given as alpha plus beta, and that is equal to minus b over a. And the product of the roots, alpha times beta, is equal to c over a. Now we can use this to look at different things relating to quadratic equations. So let's look at some examples that you are likely to see. Here we have two equations. First one, a, we have 4x squared plus 7x minus 3 equals 0, and we want to write down the sum and the product of the roots. Now remember, the sum alpha plus beta is equal to minus b over a, and the product, let me just write those quickly. The product, alpha times beta, is equal to c over a. So we can write them down. So we want to write down the product first. the sum first, and the sum would be minus b. B is 7 here, so let's write that a, b, c. So b is 7 over a is 4, and so what we get for the sum would be negative 7 over 4. The product now, the product of the roots would be c over a, and c is equal to negative 3 over 4. And so we can write down these values rather simply by just looking at the coefficients, and make sure that you have the equation in standard form as it is here, or if it's not in standard form, remember to assign the ABC correctly so that you don't get the values mixed up. Once you do that, you can write down the sum and the product of the roots. Now let's look at question B. In this one, the sum of the roots would be minus b, and b here would be minus a plus 2, and that over a, because this would be a, and this would be b, that is c. And this gives us a negative here, gives us a plus 2 over a. So the sum of the roots here is going to be a plus 2 over a. And the product of the roots in this case is going to be c over a, which is negative a over a, and that division gives us a negative 1. So we can look at the sum of the roots, as in writing them down. If you should add the roots, what they will be, it would be this, and the product of the roots, likewise here. Let's look at another example. Now here we want to write down the equation, the sum and product of whose roots are 3 and 4. So there is a quadratic equation, and the sum of the roots is 3, and the product of the roots is 4, and we want to write down that equation. So that general equation would take the shape x squared plus the sum of the roots. Remember, the sum of the roots is minus b over a, and the product of the roots would be c over a, and of course that would be equal to 0 since we're writing a quadratic equation. Now here we have it, x squared. The sum of the roots would be 3. So we'd have a negative 3x here, plus the product of the roots, which would be 4, and that would give us 0. And so our quadratic equation simplifies down to x squared minus 3x plus 4 equal 0. So we can write down, given the sum and the product of the roots, we can write down the equation, the quadratic equation that has these as its sum and product. Let's look at another example, which is a little different. Here we have the roots of this equation, 2x squared minus 4x plus 5 equals 0, are alpha and beta, and we are to find the value of 1 over alpha plus 1 over beta. So first let's write down the sum of the roots. Remember, the sum of the roots is minus b alpha plus beta is equal to minus b over a, and in this case we have a minus negative 4 over 2, and this minus here gives us a positive 2. So the sum of the roots is 2, and now let's write down the product of the roots. The product of the roots is c over a, and that is given as 5 over 2. This is a, this is b, this is c. So we have written those down. So having written these down, what is the value of this? Now let's write this as a fraction, as a single fraction. So 1 over alpha plus 1 over beta as it is. We don't have a single value for alpha. We don't have a single value for beta. What we have is a sum and a product. So let's write that as 1 over alpha plus 1 over beta. If we should add these two together, it would give us alpha plus beta over alpha times beta. And what we have now is alpha plus beta. We know that the sum is 2. And the product, we know that also is 5 over 2. So we want to divide 2 by 5 over 2, which means 2 divided by 5 over 2, which ends up being 2 times 2 over 5. And of course, we know that is 4 over 5. So we can also write down, given the equation, we can write down expressions like these, like find the value of this using different manipulations of it, 1 over alpha plus 1 over beta, etc. Let's take another one. Here we have the roots of the equation x squared minus 2x plus 3 equals 0 are alpha and beta, okay? And we want to find the equation whose roots are alpha plus 2 and beta plus 2. So first, remember, sum is equal to minus b over a, and product is c over a. So the sum of the roots is going to be minus b, which is minus 2, over a. A here is 1, a, b, c, and that gives us a positive 2. And the product is going to be 3, that's c, over a, which is 3. Now we want to find the equation whose roots are alpha plus 2 and beta plus 2. So first thing we need to do is to sum them. So what is the sum of these two roots? If we add alpha plus 2 plus beta plus 2, then what we have is alpha plus beta plus 4. And we know what alpha plus beta is. Alpha plus beta is the sum of the roots, and the sum of the roots is 2. So that would give us 2 plus 4, and that would be 6. So the sum of the roots of the equation that we need is 6. Now what about the product? Now, the product would mean that we have to multiply these two roots. So alpha plus 2 times beta plus 2 gives us, let's multiply this, alpha beta plus 2 alpha plus 2 beta plus 4. And this can be simplified as alpha times beta plus 2 alpha plus beta plus 4. And we know what these are. Alpha times beta is a product. The product is 3 plus 2. The sum of the roots is 2 plus 4. And that adds up to 3 plus 4 plus 4. And that gives us 11. And so what we want is an equation that looks like this. X squared plus sum of the roots, which is minus b over a, x, plus the product of the roots, which is c over a, equals 0. Now let's fill in these values. The sum of our roots was 6. And so what we're going to end up here with is x squared minus 6 because of that minus sign. And the product of our roots is 11. So plus 11 equals 0. And this is the equation that we need. This is pretty much how we use the sum and the product of the roots. You could look at other examples as well. There are many good books that you can go through that would give you more examples about how to deal with these kind of questions and to get you practicing. So now that you know, remember to get more practice. Remember to tie down the skill. This is how we understand it, the sum of the roots of a quadratic equation and the product of the roots of a quadratic equation. Of course, if you haven't subscribed to the channel, please do before you go. Thank you so much for watching, and continue working hard.